Hi, I'm John Brown, a graduate student in the astronomy department at OSU. In this coffee brief, I'll highlight some results from my recent paper with Paul Martini and Brett Andrews titled A Recalibration of Strongline Oxygen Abundance Diagnostics via the Direct Method and Implications for the High Redshift Universe. The correlation between stellar mass and gas phase oxygen abundance, also called the Mass-metallicity relation, is one of the primary constraints for theories of galaxy formation and evolution. In particular, the slope and turnover, as well as the dependence on star formation rate and redshift, serve as observational constraints that must be reproduced by any realistic model of galaxy evolution. Precision measurements of oxygen abundance are typically performed with what is known as the direct method, in which faint, temperature-sensitive emission lines are measured and used to infer an oxygen abundance. However, the temperature-sensitive lines are typically very faint, and thus only detectable in bright, high-excitation parts of the ISM, like H2 regions. In the past, astronomers have calibrated how the relatively bright emission lines correlate with the oxygen abundance measured from the direct method. These calibrations were then used to estimate the oxygen abundance in objects like star-forming galaxies, where the temperature-sensitive lines are too faint to detect, but the bright emission lines are still very visible. These relatively bright emission lines depend on parameters other than just metallicity, so calibrations based only on H2 regions introduce a significant bias. Previously, there was little that could be done to circumvent this calibration bias. However, with the stacking methodology from Andrews and Martini 2013, we are able to measure the faint, temperature-sensitive lines in the spectra of star-forming galaxies from the SDSS that span a wide range of excitation conditions. By stacking galaxies in terms of stellar mass and specific star formation rate relative to the median specific star formation rate at each galaxy's mass, we're able to isolate galaxies with relatively similar metallicities and excitation conditions. This allows us to calibrate how bright emission lines in galaxy spectra depend on metallicity across a wide range of excitation conditions. We derive calibrations for oxygen abundance based on bright emission lines with an added secondary dependence on the relative specific star formation rate. We apply our calibrations to galaxies in the local universe and find that most galaxies have higher metallicities than previous calibrations suggest. We also find evidence that the dependence of oxygen abundance on star formation rate is a function of stellar mass, but the extent to which this is due to systematic effects associated with the bright emission lines themselves is not yet clear. Finally, we apply our calibrations to a sample of high redshift galaxies and find evidence that the mass-metallicity star formation rate relation evolves with redshift. For the details of our new calibrations, as well as a more in-depth discussion of our results, be sure to take a look at the archive link to our paper in the description below.